what I work on. And I have been working on Temporal for over a year now, and today I'll be talking about it. It was actually one of the biggest changes in JavaScript in a really long time. So obviously, the first question, what is Temporal? Okay, so Temporal is a modern datetime API which is actually kind of a better version of the current data API, and in the current scenario, all of us use some of the libraries like Moment.js to deal with datetime in JavaScript, right? But so that actually adds up a payload, like a lot of payload to our apps, and we don't want that. So Temporal is built in, and a few other features are it's strongly typed. So basically, you have for every type of data you have a separate type to represent it instead of one thing that represents everything. It's customizable and it's highly extensible, and also it supports internationalization. But why do we even need Temporal, right? That's the second question. Well, I'm not even going to try to sugarcoat it, but the data API is terrible. And also, I think confidently say for all of us JS developers around here that we are all very scared of the data API. So, so this list here is actually all of this list was actually taken from Maggie's blog, who's one of the developers of Moment and also one of the initial architects of Temporal. And she wrote a blog and she made this list. It was the problems that were identified with date very early, and this is everything that Temporal aims to solve. She has actually listed them in order of relative disgust, and some of these, like the unwieldy areas, they can be solved. But some of them, like mutability, they cannot be solved without breaking the web, and we don't want that. So I mentioned strong typing earlier. So let's just dive into details of all the types that Temporal has. So these are all the types that Temporal has, and they are divided into two categories. Okay, so there are exact time types and there are wall clock time types. What do I mean by each of these? So exact time types, which has the date time and the instant, these are the ones that have precision up to nanoseconds. Okay, and the wall clock time types are the ones that's just how we talk about time in our day-to-day lives. Okay, so that's like, okay, it's 12 p.m. so that's plain time. That's how we talk about it. Okay, so now we're just gonna go into details for each one of these. The first one is instant. So instant is basically an exact moment in time. It has it is just a representation in up to with nanosecond precision. Okay, so it has no time zone, no real-time variance, no calendar, no location. It's purely an ever-increasing number. It's basically a timestamp. Okay, and it is represented as 11 nanoseconds since midnight of UTC, Jan 1st 1920, which is the epoch time. It can be converted to other types too. Then we have this family of plain types, which has so plain types are basically just how we talk about time. Okay, so for example, if I'm saying, okay, we have the lunch break at 12, so I would be talking about plain time. If I just say, oh, that my birthday is on 14th March, so that's me just using plain monthly. So these are all those types. But the question here is, so if I have a plain date time which represents a simple date along with time, why do I need other times like plain date or plain time which have less information, right? Why couldn't I just use the first one? That is because so we can accurately represent the data that we have. So for example, in the current date, what happens is if you want a date without the time, you would just use midnight on that date. But the thing is, due to DSE, there are some cases where the midnight doesn't even happen at all. For example, there was this case in Brazil in November, so there was no midnight at all. So but it also has a calendar and a time zone. So we have a month, we have a year, and all those things. And since it has a time zone, it also accounts for the DST changes and literally every other change that happens in the time zone. So that's the only time. Now we have some of the other types, the duration, the time zone, and the calendar. So these are auxiliary types. These are used in things like, for example, the duration is used for addition and subtraction. Like if you want to add one type to a type, we would use duration. Like we would need to add one duration to one type. So that would we need to use duration for that, okay? Or find the time elapsed between two types. And then we have time zone and calendar. You actually wouldn't need to use these directly, but they are implicitly used. But you could actually make your own custom calendars and time zones in Temporal. So you could have your own Martian calendar if you wanted. So this ends the types, and this has been a lot of theory until now. So let's just see some code. So this is a problem statement. We have to get a Unix timestamp in milliseconds. Now there's a reason why I chose this specific problem statement, okay? Because this is the number one top voted question on Stack Overflow for the current data we get, and obviously we would like to do the same thing in Temporal. Okay, so let's find out the timestamp for the current time. So we haven't actually talked about how do we find the current time in Temporal until now. This is where the now namespace comes in. Okay. So basically, Temporal now namespace, it provides you a bunch of functions which allow you to convert the current time into any of the temporal types. So since we talked about timestamp, we have to find out the timestamp. We would need to use the instant because it's the exact time. And then since we need the current time, we would actually use the first one from the list. And then after this, we actually need to find out the milliseconds. So each temporal type has a bunch of these properties, right? But not every type has all the properties. Like we only have the ones that make sense for that particular type. So only zone date time has all these things because it has everything. But for example, for type of the calendar, we don't have a zone. And combining all of that information, this is the line of code we get for getting a timestamp in milliseconds for the current time. Okay, this was an easy one. Let's just complicate things a little, and let's find out what is the date 1 month from today. Okay. So I mentioned arithmetic earlier, and that we use duration for that arithmetic. So duration actually provides 4 methods for this: add, subtract, since and until. So what add and subtract do is actually pretty obvious because it's like if you want to add a duration to a temporal type, you would use add. If you want to subtract, you would use subtract. And since and until are actually used to find the duration between two objects of the same temporal type. So that's duration arithmetic. So we know we need to use duration. And we talked about current date, so that would be temporal now. And since we only need the date, it would be plain date. Okay, so that part is pretty much clear. So how the add method works is you pass a property back to it, and it is automatically converted to a duration. So this line over here, it's how it represents how add takes the property back. And since we want to add 1 month, we just put it there. But where did the date come from? So, but before I get into details of where the date came from, I would like to give a bit context about calendars. So all of us here we probably use Gregorian calendar, which is the most commonly used calendar in the world. But there are other calendars. We cannot ignore the fact that there are other calendars. And every calendar has its own rules, its own months. So the thing is, when we try to add months, we need to consider the calendar, because that would just, it would be give us the wrong result if we just add to the wrong, like if we are using a different calendar and we add something to another calendar. I can show this an example of this. So for example, this is me not considering the calendar, and I've taken the calendar, Hebrew calendar. Okay, so I just took a plain date, and then I formatted it using Hebrew calendar, so we get the current date in Hebrew calendar. Then I added a month to it, which object is a plain date, and by default the calendar we have is the ISO calendar, which is the default machine calendar, but it's pretty much similar to the calendar we use. Like you could just convert between the two without doing any mental calculation. So we added to it, we added a month to it, but the result it gives is not exactly the date not exactly the date which would be 1 month after in Hebrew calendar. It's actually 1 month and a day apart. So that's the wrong way. So what's the right way of doing it? So the right way of doing it would be to construct the temporal plain date by passing an appropriate calendar. So first we define a calendar object, and then we constructed a plain date using that calendar object, and then we added the months, which actually gives us the right result. So this is how we just add a month to the current date in temporal. Okay, so that's the code, but one of the most common questions that I get asked a lot about temporal is, when can we use temporal? So this is about that. So temporal is at stage 3 of the TC39 process. But let me give you a bit context on how the TC39 process works. So essentially there are 4 stages of every proposal that we introduce in JavaScript. The first stage is where the proposal is just an idea. There's nothing specific. We just have an idea and we decide if it's worth pursuing. The second stage of the TC39 process is where the idea is more concrete, it's more well defined, and we have a specification, like we know what would be there and what would be there in the proposal. So when we get the complete specification ready, then we move to stage 3. This is where the temporal is in. So in stage 3, actually there are no major changes, but since temporal is so huge, we have been in stage 3 for a while. But the good news is we are almost done with any of the new changes, and this is actually the first time in a while where we are not proposing any new changes. So temporal. So I'm hopeful, and it would be there by sometime next year. And the stage 4 would be basically when it's just merged into JavaScript. And you can actually take, so the browsers are currently implementing temporal. You could track their process in the respective bug trackers, and also if you are not patient enough to wait until next year for temporal, you could use polyfills. We have a polyfill. I will actually share a QR link for the polyfill, and you could just try to use one of these polyfills in your project. And if you just want to fiddle around, try some of the code that I presented, then you could just check out a playground. So basically the temporal docs. When you open the browser console in those docs, you can use temporal there. You could just try out temporal stuff in there. So these are the QR codes to all the links that I mentioned. If you want, you could take a picture of it, or you could even, I'll upload the slides on my GitHub, so you could just check them there. And that's all. So thank you everyone. Thank you everyone for listening. Woo!